Our next presentation will be Remote FLS Testing, ready for prime time, to be presented by Dr. Alan Okranik.
Good afternoon, everyone. Thanks for the opportunity to present our paper. These are our disclosures which will not affect our presentation. So FLS is considered to be the gold standard for basic laparoscopic training and assessment. It's been mandated by the American Board of Surgery for all trainees wanting to sit their examinations. And without a doubt, in the last 5 years, the number of individuals seeking FLS certification in North America and especially around the world is growing dramatically. Currently, there are 77 accredited test centers. These majority of them are in North America. There are now 4 international test centers. And FLS certification testing is offered either at these test centers or at surgical conferences such as SAGES, also by a traveling proctor for areas where there is no test center close by, should they choose to have the proctor come to them. Without a doubt, maintaining these test centers has resulted in significant cost for the FLS program and for SAGES, and not only to the FLS program, but to individuals that may have to travel to these test centers to be tested, should there not be one close by. So it's important that in order to meet the increasing demand in a cost-effective manner, that we look at new models of offering FLS test certification. A few years ago, in 2013, we published and presented these results from a pilot study that showed that there was excellent inter-rater reliability between a remote and on-site proctor. This really was a feasibility study, and as part of this study, we identified important barriers and challenges to remote FLS proctoring. And so the purpose of this study was to assess the integrity and validity of the FLS manual skills component administered remotely in a real-world environment according to standard FLS testing protocols. And when I say a real-world environment, what we were trying to do was really simulate an individual showing up at a test center and going through all of the steps and motions that they would need to do in order to take the FLS exam. All the testing occurred at the Center for Global eHealth and Innovation at the University Health Network. We established 2 separate remote testing rooms that were connected to 2 separate remote proctors. Participants ranged from medical students that had very little experience to staff surgeons. There was a remote proctor that did all of the scoring and communicating with the test taker. There was a silent on-site proctor who was not allowed to speak. They were there to score the exam and ensure that there were no critical errors that occur that were missed by the remote proctor. A very important point is there was an invigilator or a test overseer in the room, and their role was to greet the test taker when they arrived as though they were an actual test center. And they followed the instructions of the remote proctor. They had very minimal knowledge of FLS, and they were also there to ensure the security of the test materials. This is the remote testing setup that you see here. This is one of the remote proctors. You can see he has the view of the test takers inside of their FLS box, and he also has a full view of the test taker at all times. We've previously presented on the setup here that we use for our telesimulation training. They have 2 Skype connections and 2 computers. You can also see that the remote proctor has access to his own FLS box in case he wants to demonstrate how to set up one of the tasks, although we found throughout the study that this was not actually needed. After the exam, and this is another important point, all the test materials are taken by the invigilator. They never leave the view of the remote proctor. They're placed in a sealed envelope, and they were then reviewed and scored by SAGES staff just as though they would be for a real FLS test examination. This is a very short video that just shows a few things. You can see the test taker and what this person actually sees. So this is obviously them doing the task. The remote proctor here is scoring them. Here is the invigilator that is, in this case, removing the gauze and putting it into the envelope that will be sent to SAGES. We use paired sample t-test to compare the remote proctor and on-site proctor's FLS scores, interclass correlation coefficient used to assess the inter-rater reliability. We also administered a post-test questionnaire to assess the participants' experience with remote testing. So we tested a total of 20 participants. You can see 4 medical students, 7 junior residents, and 9 more experienced residents, fellows, or staff. 11 of the participants had previous FLS experience. 6 of them were previously FLS certified. Here you can see, again, the next 2 slides just try to drive home the point of some of the important metrics with FLS testing. You can see that the mean times for each of the tasks is never different by more than 1 second. They're virtually identical, and this is reflected in the overall FLS score for each task, as well as the total FLS score. And this is obviously reflected in excellent inter-rater reliability for all 5 tasks, as well as the total score. There were no critical errors that were identified. Importantly, and this remains one of the main challenges of doing this, there were 4 sessions that experienced dropped internet connections. When we looked at these, they were all related to one of the testing rooms where 7 people were tested. In the first room, where 13 of the participants were tested, the whole experience was absolutely flawless, and in the second room, there were much more challenges. We felt this was due to some software issues on the actual computer compared to the internet itself, because we were in the same center, so there was no reason that the internet connectivity should be any different. Very briefly on some of the results from our questionnaire, 85% of the participants reported being highly satisfied with the remote FLS testing experience. 15 participants had lower satisfaction scores, and all of these were related to the internet connection challenges. There are some limitations to this study. Importantly, the team that set up the equipment was one that had a lot of experience with telesimulation. They knew how to set this up, and despite this, we still had some challenges with the connection. And so obviously, establishing this in another center where they may not have that much experience could be even more challenging. Loss of internet connectivity remains a challenge. We need to identify what the IT guidelines would be to make this run more smoothly and use computers that have no other running software. In terms of future directions, the FLS Proctor in a box is something that we're working on to assess the first limitation, so that a center that wants to do remote testing could receive all of the material that you see here with simple to follow instructions and set everything up with clean computers that have already been tested and that don't have any problems. We're also looking at doing an economic analysis to compare the costs of the remote testing model versus the traveling proctor model, which is currently being used in some circumstances. So in conclusion, remote evaluation of the FLS manual skills is feasible in a real-world testing environment and can be done to FLS standards in a secure fashion. We've demonstrated excellent inter-rater reliability. However, the internet connectivity remains a challenge, and our hope is that the Proctor in a box model will help to assess, will help the remote sites assemble the required equipment and help make the results more generalizable. Thank you very much.
Thank you. This paper is now open for discussion. Again, feel free to send questions via the app or come directly to the microphone. We do have one question through the app. Dr. Freed?
Terrific study, and when FLS was first designed, one of the criteria for it was that it should be portable and inexpensive. And one of the big barriers to its adaptation, particularly in areas outside of North America, has been the cost. So I applaud you for for doing this and for identifying the barriers to the widespread implementation, the scaling up. I just would like to ask, what would be the next steps? So you've identified some things that went wrong in the course of piloting this in your own environment. You've now developed the Proctor in a box system. So how do you go, what's the next step in order to make sure that it can be, the theoretical model will be available, for instance, in areas that are somewhat distant from traditional test centers, that it's as easy to set up as an IKEA instruction sheet, which always seems to baffle me, et cetera. So how do we go forward with this? Because I think it's very important work.
Yeah, no, thanks very much, Dr. Fried, for your comments and for your question. I think, you know, the next steps, there are several. We've sent the Proctor in a box model to various sites for feedback, so we're still refining that. I think we need to really sit down and assess the real cost of doing this and set up some real comparison to some test scenarios. So, for example, if someone wants to set up a test center in Latin America, what is the actual cost to SAGES of doing that versus the actual cost of sending the Proctor in a box and doing the remote testing, and then perhaps bringing that Proctor in a box somewhere else? And then we really need to identify clear guidelines from the IT standpoint that will help with the issues around the internet, much like we've done with the written test, where there are, you know, clear guidelines, and we can identify various tests that will need to be done before sending the equipment with the IT department of the center per se.
Dr. Duncan?
Brian Duncan from Houston, Texas. Alan, it's really neat work. And just one quick question and one quick comment. A quick question is, would wireless communication have made your connectivity problems go away?
You know, that's an excellent question. You know, the short answer is I don't know. I think in this circumstance, I do think we identified that the issue was with the computer and not with the internet. But in some circumstances, the firewalls of the hospital are actually usually the main barrier. And in that case, wireless, I absolutely agree, is the way to go, especially with the advent of, you know, 4G cellular wireless that is very, very fast. And that is, I think, is the killer app in resource-restricted settings where they may have a lot of barriers, but the internet and cellular phone usage is actually often very, very good. So.
The second comment I would make, and I hadn't thought of this until I heard your presentation today, is that this is, in my opinion, a set of telementoring. And we might bring that task force to bear and keep this model in mind when we're going through the Project 6 Summit and identifying challenges that you're experiencing, not, you know, for this kind of environment as well as for kind of the intraoperative environment.
Yeah, thanks.
Thank you.
Thank you very much.